This is an example of how we can use differentiation to look at curves, and so gain some information about it. So differentiation and coordinate geometry. So this is an exam style question as well at A level. So what we've got is the equation of a curve. So f of x is 3x cubed minus 7x squared plus 4x. And we're asked to differentiate it. So that's what the symbol there means. F dashed x means we're differentiating it. And then from that, be able to find equations for the normals at points on the curve. So just to talk about the notation here, f of x is equal to this. It's similar or very much the same as saying y is equal to 3x cubed minus 7x squared. So we could use the y and the fx interchangeably. And then f dashed x is the same as saying dy dx. So if we differentiate this, what we can do, we can use the standard thing for x as to a power, and that is if our function of x is a, which would be a constant, times by x and then to a power n, if we differentiate that, so we can create, we usually would create a table of standard differentials. So we would get f dashed x, and we could see that the n would multiply to the front, so we'd have n times a and then x, and then the n has 1 subtracted from it. So an example of that, if I put numbers into this, let's imagine that we had 5x to the power 4, then the n here is 4, and we multiply that to the front, so we have 4 times the 5, and then we would subtract 1 from the power, so that would now become a 3, so it would be 20x cubed. So if we apply that to this, then what we've got is the 3 multiplies to the front, so we get 9, and then subtract 1 from the power, makes it squared. And with the minus 7x squared, we would multiply by the 2 at the front, so we get minus 14x, and then if we knock 1 off the power of 2, it's going to go to 1, so we can just leave it like that. And if we have, so looking at how we would deal with the power being 1, if we had ax, where a is a constant, if we differentiate that, then all we get is the constant. So in our case here, we've got the 4x, and so if we differentiate that, what we get is just 4. So that's f dashed x, in other words. So f dashed x is the 9x squared minus 14x plus 4. So what we're next being asked to do is find equations of the normals at 2 points on the curve. I'm just going to draw a quick sketch of the curve, so what it might look like, so we can get a bit more information. So since we're told these 2 points, and we could see that if we put x is 0 into this, the y equals 3x cubed, then what we will get is y is 0. So if we replace x by 0 in this, 3 times 0 minus 7 times 0 plus 4 times 0 is obviously 0. So that's this point. And the same again, if we put in x is 1 into this, then we have 3 times 1 minus 7 times 1 plus 4 times 1. And so that would mean we get another point. So if we say this is that point here, 1. So we've got 2 points on the curve. And because it's a cubic, a general shape of a cubic would be something like this. So there we go, that's general shape of the cubic. And what we've got is we're looking for the normals at this point here, so 0, 0. So the normal is at 90 degrees to the tangent. So the normal in this case would look like this at that point, and the normal at this point at 1, 0 would look something like this. And so we've got to find these two equations, and then just reading further on in the question, given that the two normals meet at point P, we've got to find the point P. So actually, point P would be this point here. So we've got to find that point eventually. So this is point O, just here, and this is point A. So the first thing that we're going to do in this is we're going to take our differential here, so f dash x, and we can find the gradient of the tangent at both points O and point A. And then once we've got the gradient of the tangent, so the tangent would look like this. So if we find the gradient of the tangent at that point, then we can use the fact that they're at 90 degrees, the tangent and the normal are at 90 degrees, and that would allow us to find the equation of the normal. Similarly, at point A, so we can find the gradient of the tangent at A, and the normal and tangent will be at 90 degrees to each other. So having the gradient of the tangent will allow us to work out what the gradient of the normal is. So the first thing that I'm going to do is find the gradient of the tangent at O. So tangent at O. So to do that, I'm going to take my f dashed x, or dy dx, and I'm going to find the value of that at x is 0. So I could write that like that, f dashed at x is 0. So what I will get for that, I'll get 9 times 0 squared minus 14 times 0, and then plus 4. So that will give me that the gradient of the tangent is equal to 4, tangent at O. Similarly, if we look at the tangent at point A, then now we're finding the gradient where x is equal to 1. So that's going to be 9 times 1 squared minus 14 times 1 plus 4. And so that's going to be 9 minus 14 plus 4, which is going to give me minus 1. Now what I can do is I can use the fact that for two lines which are at 90 degrees to each other, I can take the negative reciprocal, so negative reciprocal, which to find the gradient of a line of two lines that are 90 degrees to each other. So that will mean, using that, the normal at O will have a gradient that's minus 1 over 4, because we're just taking the reciprocal of 4, which is 1 over 4, and we're making it negative. So, or we're changing the sign. So if it had been minus 4, it become positive. So since it's positive, it's going to go negative. So the gradient of the normal at O is minus 1/4, and the normal at A, since the gradient of the tangent at A was minus 1, if we take the reciprocal of that, it'd still be minus 1, but we're going to take the negative reciprocal, which is going to be plus 1. So that is the two gradients of the normals, which we've got there. Having got the gradients of the normals, we can now use the equation of a straight line to find the equation of the normal. So the equation of a straight line, we can use y minus y1 equals m, and then in brackets x minus x1. So for the normal at O, then our y coordinate, y1, is actually 0. So it's going to be y minus 0 equals, and then the gradient that we got was minus a quarter, and that's going to be times by x, and again that was 0, so x minus 0. So that gave us y equals minus a quarter x. So that's the equation of the normal at O. And if we look at the equation of the normal at A, we can use the same y minus y1 equals m x minus x1. And this time the coordinate for A is 1, 0. So that's what I was using. That's what I'm going to be using. The one at O was 0, 0. So that's what I substituted in here. So now I'm going to do that for A. So I've got, again, y minus 0, because y1 is 0. That's that value there. And then it's m, so m is 1, times by, in brackets, x minus, in this case, it's 1. So the x coordinate of point A is 1. So that will give me y equals x minus 1. So those are the two equations of our normals, which we were asked to do. So that's part B done. So next thing we've got to do is find point P. So point P is where these two normals will meet. And we do that just by equating the two equations together. So we equate this one, y equals minus a quarter x, to y equals x minus 1. So we can just equate the x parts together. So at point P, we know that x minus 1 is going to be equal to minus a quarter x. So what I'm going to do is just multiply through, first of all, by 4. I've got 4x minus 4 is equal to minus x. Take the x over the other side, so that's going to give me 5x. And in fact, set the 4 over, so that's going to give me equals 4. And actually, that's going to give me, if I divide through by 5, that's going to give me that x is equal to 4 over 5. And now, and obviously I need the other point, the other coordinate, which is the y coordinate. So since we've got x is 4 over 5, we can go back, we can pick either the equation of the normal at O or the equation of the normal at A. I'm going to choose this one, the one at A. So I'm going to say, well, y is equal to x minus 1. And so for the value of x that we've got there, that's going to be 4 over 5 minus 1, which is going to be minus 1/5. So that would mean that P is 4/5 minus 1/5 is the coordinate of P. So the next thing that we need to do, if we're looking at part D here, is we've got to find the area of triangle OPA. So I'll just change the color of my pen here so we can see what we're doing. So what we're looking for is this area here of this triangle. So what we're going to do then is we're just going to use the standard equation of a triangle, which is area equals half base times height. So in our case, the base is going to be the distance from O to A, and that's just 1. So from taking the x coordinate, we've gone from 0 to 1. So it's going to be the area is going to equal half times by the base, which is 1. And the height is the perpendicular height, which is going to be this distance here. So in other words, it's the distance from 0 down to the y coordinate there. So we've got this was 4/5 minus 1/5. So in fact, that's just going to be, that distance then is 1/5. So times 1/5. And that's equal to 1/10. I'm going to work all that out, which is 0.1 if I want it as a decimal. And that's it.